Hello students. So now that we have observed about conservation of momentum, I want to ask you a very simple question. Okay. So you can see this image right over here, right? You may have seen this even before. So this is a very simple meme. And in this case, what's happening is there is a car, metal, and you can clearly see the magnet over there. We know magnets attract metal. So as a result, they should attract the car and the car should move in the forward direction. Okay. So although you may think that this is basically a joke, but the thing is, why is it not being used? Okay. It seems a bit appealing, but what's the problem in this case? Okay. Anyone else may think that yes, this is logical, we should do this. But the problem is, there is the limitations of the laws of physics. Okay. So now before I give you the answer, I'll pause for 3 seconds. Just think about the answer, note down the answer, and then we can see that does our answer match with each other or not. Okay. So here you can clearly see that I can assume that this is basically one whole system, right? Now what is a system? A system is basically parts of objects or different objects which I am observing, right? So this is a whole system in which there is a car, okay? This magnet is attached to this car itself. So that means I will have to consider this whole one system. I cannot consider this as other object, this as other object, because this is attached to the car itself, okay? Now, tell me that in this case, this magnet is going to apply an attractive force on this metal in this direction, right? But the metal will also apply an equal and opposite force on this magnet as well in this direction, right? These are the two forces which are acting. But children, keep in mind that this is the whole one single system. So that means these two forces are internal forces. And from Newton's first law, we have understood that basically if there is motion, that motion is only going to be due to the external force, right? F external. Only an external force brings about any change in velocity or basically acceleration, which in Newton's second law, we learned that this is basically equal to the mass times acceleration of the object, okay? In terms of the law, that is basically F is equal to or basically directly proportional to the rate of change of momentum, dp by dt, okay? Anyway, the point is, there is no external force. So because there is no external force, these are internal forces, they are going to get cancelled in the system and the object will never move in any direction. Let's look at this with the perspective of conservation of momentum. Now in conservation of momentum also, we observed that whenever an external force in a system is zero, the total momentum of the system remains conserved. Okay, so the momentum does not change. Okay, so as soon as you apply this magnet here, but this is already attached to this, we can consider that initially when all of this being done, that in that situation the whole system is at rest. So whatever will happen, eventually this system is not going to move because the external force is still zero. Okay, in a situation where you're basically, let's say you are on a wheelchair like, and you try to push a table. So what usually happens when you push the table moves in the opposite direction, but your body also moves in the backward direction. These two momentum basically cancels each other out, and eventually the total momentum of the system remains conserved. Here also it is going to happen this in the same way, but the thing is, these two objects are going to move towards each other. Basically the direction is going to be opposite, right, as compared to this example, but still the overall system is not going to move in any direction. Okay, so now I think you have understood that what are the forces which needs to be considered as internal force and what is going to be the external force and how these law apply. Okay, so the next time any of your friend or anyone else sees this meme and they ask, why can't we use this seems plausible, so you can explain them that no, Newton's laws of physics restrict us to do something like this. Thank you.